This video is meant to cover the data collection portion for the atomic coatings size of an atom. In this lab, what we're going to be doing is taking pieces of galvanized iron, and galvanized iron is created by spraying a thin layer of zinc over the top of the iron. Now, zinc is more reactive and it'll react with the air and also water faster than and more readily than iron will. And so one of the things that it does is by reacting, that outer coating reacting, it protects the underlying iron that's laying below the surface, which then helps to preserve that iron. So instead of that iron rusting out, it will be protected by this galvanized zinc. We use these all the time. We use like galvanized nails on things that we're doing outside. Rain gutters sometimes will be galvanized, heating ducts, screws, anything that's going to be exposed to the environment. Iron's a great metal, but because it's so reactive and it will break down over time, it's a really nice application to be able to have this zinc coating protecting it. The equation that you're going to see in that background is this one here. So we're taking this zinc, which is on the surface of the iron, and we're going to react that with hydrochloric acid. And so ideally what we're going to do is we're going to strip away the zinc layer from that piece of metal, and that's actually going to form two things. It'll form zinc chloride and then hydrogen gas. So essentially what's happening here is the zinc is having its electrons ripped away from it by the hydrogen ions that are present in HCl. So those hydrogens are each going to take one electron from every zinc atom, and then those hydrogen atoms are going to combine to form that hydrogen gas. Because of this, it's super important that I am mindful of my environment, making sure there's no open flames or sparks, anything that would potentially ignite the hydrogen gas in this oxygen-rich environment that would be dangerous. So another thing here, and this is more like what we learned in ninth grade, is that once that zinc has lost electrons, it's going to form a positive charge. We called those cations in ninth grade, and we'll be coming back to these concepts in this unit. And that is going to therefore be attracted to the chlorine, which is actually existing in the solution as Cl with a negative charge. It's an anion. So that Zn plus the Cl is going to form zinc chloride. All right, so in this lab, it's going to be really important that all of these measurements are being made accurately. Normally, we only are able to do 1 or 2 trials per group, simply because the 6 molar hydrochloric acid isn't exactly cheap. And this galvanized iron, it's not expensive, but it's just not something that we have in mass quantities. However, because no one else is in the room with me and I'm kind of bored, we're actually going to do 4 trials. I want us to make sure that we have really good data. Sometimes if we only do 2 trials, we're not going to get good data, but we normally compare this against everybody's data, so we normally have a really large data set. So for the purpose of this lab, what I would love for you guys to do in your notability document is go ahead and erase trial 1 or like white it out, and then go ahead and divide the column for trial 1 in half, and then do the same thing for trial 2, and then go ahead and put down trial 1, 2, 3, and 4. So we're going to go ahead and collect the data in this video for all of that. We'll start by getting the length and width of our pieces. So as I'm going through that, you're going to maybe have to pause the video and get those measurements. And then I'll go ahead and give you the mass initial. So we'll fill those out right away. Then we're going to go ahead and do the lab and rinse off our pieces once it's done reacting, and you'll get this piece of data. After that, you should be able to calculate all of the rest of this just by following the post-lab calculations section. So we're just going to get this 4 pieces of data here for all 4 trials. All right, this is going to be the length for our trial 1 piece of galvanized iron. And then we'll go ahead and get a width on that. Again, I'm starting at the 1 and going from there. Hold on right there, that's what we want. Again, you're just trying to get accuracy to the 10th place. Now, normally we would estimate to the 100th place, but in the lab directions, that difference isn't going to matter. All right, in our next one, so that was for trial 1. Let's go ahead and get to trial 2. Let me get this on there first. Perfect. So that'll be the length and then width. Again, let me get that focused. Okay, so that's trial 2. Then trial 3. Again, go nearest 10th. That would be the length, and then here's the width. And then finally, trial 4. Let me get this organized here a little bit. That's the length, and then here's your width. Hold on. And always starting at the 1. All right, so that's the length and width data for all 4 trials. The next thing that we need is that initial mass. So we'll do that one at a time in the next section. All right, so trial 1, initial mass. Trial 2, initial mass. Trial 3. And last but not least, trial 4. All right, so the next part of this is I'm placing each one of my pieces. So this is trial 1, 2, 3, and 4. And I do have those labeled on the paper underneath so I can keep them straight. And to each one of these trials, I'm going to add 50 milliliters of 6 molar hydrochloric acid. And again, one of the things we should expect to see is a lot of bubbling occurring as the acid is reacting with the zinc. And again, as a reminder, what's happening there is that the hydrogen ions are pulling electrons away from zinc atoms. And in doing so, those hydrogen atoms are finding one another, forming hydrogen gas, and that's escaping out of the solution. And then zinc is going to find chlorine, or specifically the chloride anion, and it's going to form zinc chloride. So you're seeing that reaction occur there. So I'll let that go to completion. Reaction happened very vigorously at first and it's kind of slowing down. Just want to make sure that nothing got left unreacted on the bottom, so I'm going to move these around just a little bit here. Well, I'm going to try. Just to make sure. And really, it is important to be patient The other thing is we don't want this to start overreacting. So if we start seeing a color change in the reaction beaker, it just means that we went a little bit too far. So that means that the hydrochloric acid would have reacted with the zinc and would have removed the zinc, but then it would have also started to react with the iron. So we're gonna go ahead and give that a little bit of a swirl. And again, we're just making sure that no major color changes are occurring. Still some really good bubbling happening there. Okay, I'm gonna go ahead and pour about 200 milliliters of distilled water in just to neutralize this. It's not really gonna neutralize it. That was a bad choice of words. It will dilute it, but it will not neutralize it. So we're gonna dilute the acid here just to slow down the reaction. And doing that in the exact same order, so these will have been exposed for about the same length of time. Plenty of room for error, even just within that procedure. The next thing I'm going to do is just go ahead and pour this into a waste beaker off camera. And then I will be removing the individual pieces of zinc and rinsing those off. So I'm just gonna go ahead and take the zinc off of here and rinsing those off. So I'm gonna finish that process off camera and then I will give you your final masses. Okay, now that we have removed most, if not all, of the zinc coating from this piece of galvanized iron, I just wanted to have you look at a side-by-side comparison looking at the surface. So this was an original piece of that galvanized iron and you can see it's very shiny. It has good luster, but also you can notice that the surface looks rough in comparison to the reacted piece. So now, yeah, there is still some shininess there, but it's not nearly the same. And then also the actual surface of the piece has been altered. It seems like it's smoother and not quite as rough. So that's just a side-by-side comparison just for your information. All right, the last piece of data that you guys need in order to do the calculations is just the final masses. One of the things I tried to do is make sure that every single one of these pieces was rinsed off and then dried so that the only thing you would be getting is the dried mass, not anything where the water was influencing the outcome. So this is trial 1. Trial 2. Trial 3. And last but not least, trial 4. All right, and there you have it. So data for 4 trials of this, you should be able to complete the next steps. I will post a follow-up video doing one set of the calculations, just because historically, even reading the directions step by step sometimes is confusing to students. So I will post one additional calculations video walking you through the how to do the calculations for one set of data.